And we are live, and I want to welcome everybody. This is SIG API Machinery for Kubernetes Open Source. Our bi-weekly meeting today is May 13th. Almost half of May is already gone of 2026. And we have a really large agenda today, which is great because sometimes we don't have a large agenda. And then karma comes back and we have all these topics. So let's get to it. And thank you, Omar, for joining. We were just briefly chatting about your topic, but we can do that one first. I see David ahead of the meeting put some comments. So let's talk about this.
Yeah, thank you. So currently the HPA has two active GA APIs, V1 and V2, and we round trip between those two via annotations. And we would like to maybe go with a better approach here. And we came up with a couple of solutions, and we talk about API machinery and stuff, but we haven't decided what is the best option yet. We talked with Michael yesterday. Hi, Michael. And we talked about the opportunity maybe to use storage migration. But we don't know for sure if that's the right approach here and what should be doing to make things better. And because currently we're maintaining like two different API and round trip between those two, and this make a lot of noise and technical overhead.
So I want to understand your goal for deprecation. I do not think we would deprecate and then later remove, right? So I think that deprecation would be fine, like an intent, like we're not going to do this again, or we're not going to do this anymore, or we suggest use a different field. But I would expect the field that we deprecate to continue working forever. So does that match what you're trying to achieve?
Could we, for example, add a new field for V2 API and then say that if V1 client read that object, it will be lost in V2? Is that something we can achieve?
I wouldn't expect a GA version to stop using a particular field or stop honoring a particular field or stop returning a particular field, because I would expect older clients for that GA version to be able to work forever without ever updating. Does that make sense?
Can you maybe elaborate more a bit?
So when you say you would add a new V2 field and remove an existing field on a V1 to V2 boundary, I don't think I would expect that to happen, because I have my V1 fields now and I have my V2 fields now, and I would expect to be able to have two different clients continue to interact in the way they've been interacting before without any changes for the entire life of Kubernetes.
I think the concern is around round tripping, right? So, for example, like you create the API with a V2 API, and then a client with a V1 API goes ahead and writes to it. It doesn't know about the new fields that have been added to V2, which is why they've been storing it in annotations. So when it goes to write back, it doesn't store those fields, so it never writes it back.
Let me provide some additional background. So basically the long-term goal, at least one of them that the SIG autoscaling was considering, is currently there are two versions supported, V1 and V2. The goal was basically, we want to improve autoscaling capabilities. And so we started working with the V2 version, and that's where we have those additional capabilities. Because like Michael was saying, we always promise forwards and backwards compatibility. We have to be able to round trip any version in any direction, which means forward is not a problem for V1 to V2, because all the fields from V1 were perfectly working in V2, and they have their own counterparts. They just moved. The particular problem here is that the V2 functionality, which is slowly growing because of all the other HPAs, that's the one that is being actively worked on, and it grows with additional features. For the V2 version, we always have to be able to round trip through V1 and back to V2 and get the same result. So the annotations in questions are the annotation that we are currently using to cover or to handle those fields that are not existent in V1 but exist in V2. One of the long-term goals, and at least it's one of the topics that was discussed and is linked in the document in the agenda, was that potentially, because as you mentioned, we won't be able to get rid of. We were considering, or the autoscaling was considering, copying the entire or as much as possible of the V2 into V1 for the ability to round trip. And the annotation, or rather the deprecation of those annotations, would serve, and that's where the storage migration comes into play, would serve the ability to get rid of eventually the support of those annotation during the round tripping. So to answering a little bit longer your question, if I have a very old client Go that is talking with V1, that client will continue working because you're not working with new fields that you're not aware of. Only the V2 will be somewhat impacted, or users of the V2 that might be requesting the same resource with V1. But I doubt anyone is doing something like that. Does that provide a little bit more clarity and the goal around deprecating annotations somehow?
I understand the desire. I think we know more now than we've made several mistakes with HPA. The can't read HPA in like Cube 1.6 or whatever it was might have been the most epic. But even though it's not an API field, someone with V1 today could change the annotation, write it, and get a different result stored back, right?
Yeah,
I'm
sadly,
not excited
that
about breaking that. I would say that
yeah.
for every new field, it definitely makes sense to do not that.
Yeah, like going forward, following the same approach with HPA we've done with other things. You add a field in a new version, add the same field to the old version. The server can round trip on its current Go types across all versions, and old clients linked against old types will drop those fields. Like, we just accept that today. I think that's a reasonable thing to do going forward with new stuff in HPA. What we do with the existing things we stuff into annotations, I don't know.
Basically we'll just bite the bullet and we will continue suffering with what we have forever, kinda.
Our options are the things we currently put in annotations, we keep putting in annotations forever. We don't touch those. New fields in different parts of the object, we add to V1 and V2 and just round trip. And old clients will drop those fields on round trip in V1, just like they do in every other API. And like, we're okay with that. That's one option. The second option is on read, we will continue accepting annotations and turning them into like fields internally. But on write, like, we'll actually put the fields into V1 proper. And so on write, like, we will output fields as fields, and V1 clients against old Go types will drop them on round trip. But if a client happened to be like writing against V1 and fiddling with annotations directly, like, and then sending that back to us, we'll still read the annotations and like that'll convert internally. And like, that's sort of a middle ground option. Because we could have annotation persistent stuff in storage. I think we have to keep accepting annotations in the read path and converting them kind of forever. But maybe it would make life easier to have them as actual proper fields also. Maybe, I don't know. I think I left a bunch of comments in the linked doc as well. This sort of reminds me of like some of the things you have to jump through to represent data in two parts of the object, or potentially represent it in two parts of the object. Reminded me of things we did with custom resource versions when we went from a singular version in V1 Beta 1 to multiple versions. And like the hoops we had to jump through to say, like, we're going to represent this data as top level fields, but also in a list of versions. And here's the rules to write it out to both places, and they both have to be identical if you specify both. Maybe something like that would be relevant. Like, we're going to write it to annotations and we're going to write it to fields. And then if it comes back and like both come back, they have to match. If one got dropped, then fine. It must have been an old client that dropped it. We'll use the annotations. Maybe something like that would be relevant. I don't know if this is less work than what you're doing today. Like, if the goal is to save work and make it easier, I don't know that this is easier, honestly, but you could investigate that.
I mean, definitely starting with, for all the new work, just go with fields in both V2 and V1 is unblocking the work that the SIG autoscaling is working on.
Yeah, I wouldn't add new annotations and like new things into annotations. So new things you want to do in V2, add it to V2, add it to V1 as a field, round trip between the fields. Old clients will drop it if they talk to V1. That seems fine to me and consistent with everything else we do.
Yeah, I think that is a good starting point, and the rest will be we'll eventually figure it out. I know. Omar, any other questions, comments?
No. That seems a good way to continue. Yeah. Thank you.
Okay. We're all good, Fede. Thanks.
Thank you. Omar, maybe can you briefly, I'm taking notes and we'll see what the transcribe says, but can you briefly capture, the outcome?
Yeah, I'll write it on the doc. Sure.
Thank you. Very good. Do we have the second person, Kei Supanikar?
Yeah, I'm Ketan. I'm here.
Oh, okay. How are you?
Good. How are you?
Yeah, good. Thank you. Thank you for coming. So you're next. You're up.
Okay, so I can present, right?
I have to make you presenter for that. Hold on. Where is this? Here, more. Make co-hosts. I think you can present with that. Give it a try.
Okay. Share. Screens, desktop 2, share. Open system. Oh, I think there is some system thing. Okay, just give me once. Okay, sorry.
It's okay. You want me to present this issue or something else?
Yeah. I think if I quit and reopen, I might leave the meeting. So yeah, maybe if you can present, that helps.
I will. Let me start presenting again. But yeah, get started, please.
Yeah. So this is basically adding basically big of one dispatch for selectable fields. So right now the selectable fields, when we kind of have a watch on that, we kind of do a complete scan, right, of all the watchers, and that kind of impedes performance at scale. So we are proposing like adding the trigger functions for selectable fields so that we get O of one dispatch. And also the thing is, in our use case, we wanted to have the watch with for field selectors with multiple values. So we wanted the support for the in operator. So if we kind of do both of these things, right, have the trigger function wired in for the selectable fields, and then have that support for the in operator, right? This helps a lot for the scale that we wanted to kind of achieve, basically 60,000 watchers and more on the API server for our CRD watching use case. So yeah, this is my first time kind of presenting and engaging with the community. So yeah, I kind of used Claude to kind of put up the code, and definitely there is a lot of performance benefits if we kind of go with this, and also many other projects which use CRDs, like many other for their use cases, right? Will get the benefits of the Kubernetes native resources, right? The pods and all those native objects which get this big of one routing, right?
Okay. So this is not a cap yet, right? It's a
Yeah, so I was not sure of how to kind of proceed. So I had initially created this announcement issue and got comments from uh, David Eats. Yeah, he had initially had went with like using labels to kind of add like a this trigger function for labels and stuff like that. Again, pardon my ignorance on some of the internals.
it's okay.
Yeah, but yeah, the goal was to basically have the big orphan dispatch for uh, entity, and that in entity initially was the labels that kind of had proposed, but then yeah, David commented that labels are kind of like more dynamic and can be added, can be removed, and stuff like that. But we want something which is more spec defined. So selectable fields is the way to kind of wire in that routing. Yeah. And then
So I'm not sure everyone understands what you're trying to describe. So I think you have observed that there is an in-memory index held for pod spec node name
yes,
inside of a structure that logically allows almost any kind of pre-index to be pre-computed if you know what it is. And you are asking for a way to have a CRD specify an index to maintain in the same spot. Is that correct?
yes.
Okay. So given that description,
Mhm.
do people have an opinion on this? How many people even remember that this exists? Might be a question. I think there were only 3 of us who did it originally. It was me, Wojtek, Jordan might have been there, and one person doing an implementation.
Yeah, I don't really know what the implications are of taking a thing which we have exactly one singleton instance of that has one single field. I agree the structure looks like it supports multiple and arbitrary. I don't actually know if it works. If you have multiple things intersecting and they both change at the same time, like in opposite directions, I don't actually know what happens. So yeah, I'm not opposed necessarily to testing that and seeing how it works and seeing how it performs. And David and I did not build it. David and I observed it.
That makes
Go ahead.
That makes sense to me. I agree that pre-work there to be sure it actually even does. Like, I don't know what it looks like in terms of atomicity. So, right, we build this and we know the one we have today from the very beginning. I don't know what would happen when you have a CRD and you just add and change one. Right. If you chose to dynamically add one of these, I don't know. Hopefully it would work right. You'd have to find out. Joe.
Yeah, I had a similar thought, which is I don't remember us having built like a really general purpose indexing system. I know we've built support for a couple particular fields, so that seems like the starting point is like, what should you're going to be building an indexing system if you can select off multiple fields, hash those together. How does all that work? And if we're going to do that, then that we're giving CRD authors the ability to create an index, which takes up memory. So there's some implications to that. I noticed in this proposal, it was basically the idea was, well, if you have a selectable field, we're just going to start indexing that. I think we should be really careful there. If a CRD author has built a CRD and has a bunch of selectable fields today and they weren't indexed, then the memory profile is going to change if we just automatically start indexing all of those.
Especially if we do it generically and turn all selectable fields from all types into indexes. Like right now, I think namespace and name are selectable fields on every type. And so if those become indexes on every type, that's going to significantly change how we like profile things. Like namespace and name watches are partitioned by namespace and name in a special case way today, and so I don't think we would want to pay the cost of also indexing on those fields in a generic way along with other arbitrary selectable fields. Again, like I'm not opposed to improving this as long as we can prove it's correct, but doing a thing that immediately turns all selectable fields into indexes, I'm not sure is how I would approach it.
Yeah, I think it has to be opt-in, and I don't think we could break large-scale use cases today just because we're like, oh, we think everything should be indexed, and so your memory profile is totally different, your clusters break. So I think there would have to be a mechanism by which you opt in, and then there's a big question of like, what are the actors and roles that are allowed to create indices, and how do we set that up? Is it just any CRD author, you just pull a CRD and just use up as much memory as it needs, or how are we going to do that?
We have several hands. I don't know if they are staying or not, and who was first? David, Marek?
Marek's before me. If that was Joe's comment, then it's Marek.
Okay. Yeah. To what Joe said about the memory, indexing is always a trade-off, and I don't see in the proposal showing the trade-off. I don't think it's free for memory, and the trade-off decision, it's not necessarily the CRD creator. It's depending on your machine profile, like your memory available, you want to make this trade-off. So that's a person that needs to understand the infrastructure underneath. So that's not the decision of CRD author to index everything. And that technically, from his perspective, it might seem, oh, we need to exactly index everything. But on the other side, maybe administrator would prefer they're running on low memory node and they would prefer to pay the CPU cost. So I don't think it's a decision of even CRD, what API server index and what not. That's from me.
Actually, that's almost exactly what I want to talk about, and I'm not sure I agree. So this originally came in for labels. And to me, for labels, it was clear that labels and annotations are the domain of the person using the cluster. And so there was no way to have a CRD author know which labels would be good to select on. But for fields, it seems far more obvious to me that a CRD author would know the usage of the fields and create good indexes. I agree, not all selectable fields. But if a CRD author knew that the primary use was going to do something like a node name select, I would definitely want that cluster admin to be able to express that. Right? You think about things that run per node, and there's actually a fair number of them these days. And you have an agent that needs to select the ones by node. So we added a way for them to actually do a field selector for that and a way to authorize based on that. It does seem reasonably natural to me that the CRD author would know, yeah, this one needs to be indexed because it's what my list watches are based on.
And I would just separate, he might have a suggestion or he knows from who decides, like, and who is making the trade-off. So recommendation versus actuation.
It could be some of the biggest use cases of this aren't CRDs, they're the in-tree APIs, and somebody knows that they have a specific field or label that really matters for their workload, and they want to build index on that.
Do you know of one? I actually would have expected to have Merrick or Wojtek come tell me I need another item in this map, if that were the case.
I removed recently an index, so I don't know if, or I will let you know if there is more, but we removed recently a pod index for namespaces, but not for watch, but for storage.
How would you have a cluster admin express their willingness to do an index or not on a type that is not built into Q?
I don't know, full domain name, like have a way to reference and like.
So you think GKE would expose that to me so that I could have my node extension and then add my index?
I mean, I think GKE would prefer to control it than leaving it totally how much memory GKE uses to users.
What if we gave cluster admins like GKE the ability to decide, no, you won't run the indexes, and
that word, yeah,
default that to on for everyone who wants to have their normal clusters work as the CRD author intended?
That might be my suggestion. Like it's up to the administrator to pick. So the mechanism to allow it should be, can be default and different, but should be selected by the admin.
Yeah, maybe we'd be able to do something like we did for admission, where you can select this is the by default we'll honor these or not, and then select individually if you wanted a fully qualified name. I find the idea reasonable. I don't think it is small, even though the POC PR seemed small. I bet the path would be actually significantly longer for you. And I'd say if you expressed two ideas. One idea was for indexing, and the other idea was for expanding the grammar. I would suggest choosing which one's more important to you, and maybe not pursuing them together, because
I see.
I say that because I believe there's actually a PR somewhere about expanding the field selection grammar that has struggled to gain traction. So if you couple them together, there's no guarantee you're going to get traction here. So even though people, at least from what I gather here, there could be a path to adding this, that's not the same as the people here signing up for their review time to do it.
Okay. So two solutions. So split it up, and then once we split it up for this use case for indexing, we need to kind of prove that it kind of doesn't break any existing flows, and then get some quality reviews. Or I'm not sure I understand.
I think there's a couple of things that need to happen early. One is figure out what needs to happen to put an index core into the system. I mean, SQL, like a huge amount of what it does is query planning and indexing and making all of those things work together in a nice way. It sounds easy when you're saying, oh, I just want to select up this one field, but if you're selecting up multiple fields and one of those fields is indexed and the other ones aren't, query plan needs to be smart about that. And so that gets pretty complicated pretty quick. So having that core and then very carefully choosing a pathway by which we start exposing that capability through the API bit by bit would seem like the kind of the responsible way of rolling something like this out.
Okay, yeah, that's
would
for
be
the
in addition to the stuff that Jordan mentioned about can you add and remove these? What happens if they race? Sort of questions, right, Joe?
Yeah, all of that needs to be kind of thought through.
So when you say add and remove, meaning the CRD definition, okay, gets updated in one thread and then gets removed, and okay.
Yeah, I think we completely tear down storage and rebuild it when the CRD spec changes. So I would guess that it, as long as it's part of that storage construction, it probably works fine, but it's not tested. Like anytime we have exactly one instance of a thing in tree that doesn't have multiple per object, like we just find edges when we start making it dynamic or making it multiple, or yeah. So
I see.
Find all the edges.
I see. Okay. So the opt-in part of it and the edge cases regarding dynamic add and deletes. Yes. Okay. So these are the two concerns around the. Okay.
You're going to tease out all kinds of stuff, right? So if you have a multi-version CRD, the version that is actually indexed might be one version, and then the field that you actually see from a user, if you're looking at it from the perspective of another version, is going to be different. And those things just kind of compound to make this really tricky.
I see. Okay.
So it sounds like in concept, we are not fundamentally against, but I'll say that like for my part, and I guess if someone disagrees, they can say it, but I don't think so. For my part, this probably wouldn't end up near the top of my list for review bandwidth. I'm not sure where it ends up for everybody else.
Yeah, I'd have to think about it. Having a response, like if there was a PR that was proposing a very nice incremental way that explained how we could get from like where we are today to something that has some useful things, I could imagine helping craft that path and doing some of the early ones. But if we're going to try and do like a ton of work in one release, it's going to take up a ton of time. I'm not going to have all that.
If you were thinking about it, Joe, and there was someone who was inspired to do work, would you be more inspired as a reviewer to look at work related to an index or at work related to extending the field selection grammar?
Ooh, that's a good question. I think the field selection adds a lot of value for people today and then gets accelerated by having indexes later. Today, if you had the indexes first but didn't have a lot of field selection, you get to do certain things with very specific use cases. But I actually think that the indices, it's tricky because, right, you could end up building field selection that's almost impossible to index. So being aware that you're going to do both has some value. Like being totally ignorant of one side while you're working on the other can lead to maybe bad choices. But I think in terms of like the most value for the most people, I actually think the selectors is probably more tractable.
So there's my hint to you.
Okay.
Some of that just comes from knowing that I believe Joe has tried to tackle the grammar thing at least once before, right?
Yeah. So the problem with field selector is it was thrown in very quickly a long time ago, and its grammar is just a string split. So if you try and expand that grammar, it's going to be tricky. So I can share. I don't know if I can grab it right now. There are some proposals that had ways by which we could incrementally improve our selection mechanisms to build out more query capabilities. And I think that's a really interesting thing to look at and build off of. I'll try and find that.
Okay.
So this was super good, but full of information. Maybe I don't know your name. Kei Supanikar.
Ketan.
Ketan. If you can capture and then maybe tag Joe, Jordan, and David your recollection of next steps and suggestions, that would be great. So we keep it for posterity. Sounds good?
Okay, yeah, thank you.
Yeah. Okay, and I think we have Aaron next, but I did want to notice that behind our last topic, you have a really windy tree behind you. Be careful there in your window. Okay, Aaron,
Yeah.
you can.
Okay.
Yes.
Thank you.
Yeah. Aaron, all yours.
Great. Yeah. So in 136, we merged a change. We essentially put fields v1 raw access behind a set of accessors where you can access it through either bytes or an intern string using goes unique. And then we made it opt-in. And so the reason for doing this is to allow for string interning for managed fields. As it's like you scroll down, like essentially right now, if a pod, like if you have a daemon set that has a bunch of pods, all the managed fields information is copied a bunch in memory in the API server. So we want to make this change to reduce the amount of memory in the API server for these common cases. And like we see, it's like between like 5 to 25%, just depending on how many managed fields there are. I mean, it scales up proportional to the pods. So this is a change that we're hoping to make. And it's opt-in currently behind a build tag. And so I just wanted to maybe discuss here because essentially we would like to use this in GKE first as the proving grounds for this because we would like this change. But before doing that, we were just hoping to get some kind of community alignment on if, GKE were to do this and kind of verify this ability and performance of this, that we all think it has, then that we could eventually toggle this in open source to not be the opt-in because we don't want to carry this as a patch indefinitely. So I just wanted to kind of bring that to the front. And I think for OSS, the main concern would be client usage. And for the clients, the idea would be that we would deprecate this, kind of like look for those people, message them, potentially send PRs out, or at least just like ping them to that they have to use the accessors. And once they use the accessors, everything would work as expected. It's just right now if they directly access fields v1 raw, that would eventually like break them if we when we went to flip this switch. They just have to update to the latest version of the import there. So yeah, I just wanted to kind of bring this up and understand if folks here had concerns or I see some hands up.
Before David goes, just the release schedule in that doc is not accurate. That was like the earliest possible, but if we're proposing to be the guinea pigs for the behavior and the savings of this, I think there's a question mark number of releases in the middle there where we would opt into it and say, we saw no issues at scale and we saw this savings at scale. And then like an eventual, could we reverse the polarity and say the accessor interned version is the default, have some number of releases where if this causes you problems, you can build tag yourself back to the bytes access. Anyway,
totally. Yeah, I can update the numbers, whatever even align on here. But yeah, this isn't a default. Apologies for that. Yeah, this can be X releases out. I think the idea is just eventually we could drop it. That those numbers are not. I can update it after this meeting. But yeah, David, do you want to just?
Yeah, updating every client in the world has gone so well for us in the past. Luckily, there's not many of these. I don't think. Thinking through what this means. When people would notice, right? As I recall, and this is just sort of like for the record thing, the content actually being stored is identical, right? Like in etcd, you can't tell the difference.
Right. Wire format is identical.
Content on the wire looks identical. What happens is someone goes and updates their client and then rebuilds, sees no apparent issue in the rebuild, then goes and runs and it just doesn't work. And the failure mode for doesn't work will vary depending on exactly how they use it. But
no, the rebuild will fail. Like it's a compile error.
It'll be a compiler error.
And the fix is to switch to the accessor. So like if the only reason they would see an issue is if they were directly accessing the .raw byte slice field.
Yeah, people do that.
Sure.
So okay.
When they hit a build failure, the solution is use the accessor. And if there's some number of releases where the accessor is present and usable, whichever way you build tagged, like you can straddle releases. You can use the accessors now and keep using them in the future, and behavior is the same.
That is far more obvious than I was thinking. Yeah, that sounds fine to me. I mean,
yeah, just to maybe put that in concrete, exactly. The idea would be that they can bump the client library usage to use the accessor, and then it would still work. Like we don't have to change anything. They just have to get it before we did the flip. But yeah, exactly. I think hopefully Jordan, yeah, exactly. That would be the progression.
And when we do the flip, if they hadn't yet switched to accessors, when they did the bump to the version that flipped to the interned string, then they would get a compile error if they hadn't switched to accessors, and they could switch at that point. And if they were wanting to phase it in before they did that bump, like I think 136 released with accessors, so they could make that change at any point now.
Yeah, they can make it now, exactly, if they use the latest version of it, exactly.
That sounds fine for me. I think the only people that would realistically suffer are people trying to bring together multiple dependencies that all depend on this, and they have one code base that all has to agree on a version at the same time. So I'd be happy with that. And I'd be ready to go whenever y'all said it worked. Am I going to be realistically, I don't plan to switch build tags for Red Hat. I don't know if other people plan to switch. So I don't know whether you're waiting for anybody else.
For sure.
Mostly we're waiting to prove this out at scale. Like there are no problems and the benefits are measurable. Yeah, that's what we're waiting to prove out. So 136 penetration and soaking and like measuring fleet resource use. That's kind of what we're waiting for.
Both in some open source CI and in our internal fleet.
Cool. Awesome. Yeah. So it sounds like obviously I'll update the plan and make it more proposed, but it sounds like, yeah, there's alignment that folks would be okay with flipping that bit. So awesome. So yeah, the idea then we can come back just when it, hope fingers crossed, works. Then we can flip the bit and we can, we can do the deprecation, explain to the clients, wait an appropriate soak time, then flip it. So awesome.
Cool. Yeah. And instead of release numbers, let's put like conditions, like once these things are true and X time or releases has passed, like what, and then we can fill in like the specifics around the preconditions and like how long will we let it sit in that state? Then we'll flip the default. And then how long will we sit in that state? And then we'll remove the old build tag version with some call out for like, if we discover issues or like significant blockers to removing the old build tag thing, like we'll, take that into account. So that would be a good way.
Awesome. Yeah. So I'll get that out then, this document with it. Great. This is super awesome. Cool. I think that's everything. Yeah. And I'll just make that conditions list and then we can maybe try to progress this internally. Cool. Awesome. Thank you. I think that's it for my side.
Yeah, hey folks. Yeah, so next thing up, basically we talked about this 4 weeks ago in the last SIG API Machinery meeting, but some important folks like Joe and David were out. So in the meantime, I created this PR that basically allows for resource versions to be, or just the entire object status to be passed on delete API calls, and that includes resource versions. I added that as well in this change, but basically just wanted to hammer this out, make sure that both David and Joe are on board with kind of this approach. Basically adding some extra changes into the client. That's mostly just adding this delete with object function that returns the object along with an error if like an error occurs Otherwise, it's the exact same thing as a delete call. And then inside of the API server, we pass along the resource version when we get an object back from the delete call. So those are really the two main changes. There's a lot of code here just because it's a lot of generators, but the main thing is adding that return a resource version when the actual API call happens, and then as well expose a way for the client to actually get the object back on a delete call.
Did you want to talk about the handling when the server, when the object is deleted concurrently with the server's handling?
Yeah, so that is.
I've got just a question about behavior here. Most of the time when I do a delete, like I do a delete pod,
Yep.
or I do a delete anything that has a finalizer, it doesn't actually delete. And so what do I get back?
It's going to be whatever the API server sees as the object at that point in time. So if it's doing like a graceful deletion or something along those lines, it's just going to return the object at that point in time, even though it's what the deletion like actual action was. So applying that finalizer, applying that at that point in time, or applying the deletion timestamp at that point in time with that object should be what it returns.
So like if I have a finalizer on my config map and I delete the config map, I'm going to get back the config map with a deletion timestamp. And yeah, I'm going to get...
What does the server return? Does the server return the object or does it return a status?
It depends on the object type, right? Like some of them are delete with object and some of them are delete like. So it depends on how it's configured. But yeah, some of them will return statuses, some of them will return the full object.
Is the condition where the object was removed from etcd and where a deletion timestamp was merely added, are those distinguishable in the statuses we get back?
I haven't looked at that.
I mean, in some ways, I'm not sure. Like, I would like it to be distinguishable. That's a little bit orthogonal to what was the resource version of the persistence of my delete request. Like, whether it was deleted or not, it's useful to know what was the resource version of the thing I just did, so I can wait for my store to catch up, whether it was an update with a deletion timestamp or a deletion. Like,
maybe leading with that would help. So like, what is the point? Because I look at this and I'm like, we deleted it and we gave you back the object. And I'm like,
the
so
point
the
is to get the resource. We want the resource version of the request I just submitted, so we can wait for our store to be at least that fresh before we keep doing more things to reconcile this object.
Yeah, and we can do that easily with create and update calls, but delete calls at this point in time either don't return the resource version or in terms of the client, don't even return the object at all. It just returns like, oh, I got an error, or like I succeeded. But there's no like way for the actual like Golang client to currently provide like the actual object.
Yeah, it's knowing the resource version of the thing, of the write that happened, so you can
and it doesn't matter.
Back off if you're stale if you haven't observed that write yet.
Yeah, and it doesn't matter if that write was just like a deletion timestamp, like patch or something along those lines. It's just the like being able to know what resource version that write was at.
Yeah. I followed along with this close enough, I guess. I didn't realize that we actually have different behavior depending on the API. So I guess there's two ways of looking at this. One is that we have a REST API that works a certain way, and we have a Go client, and we can expose the way that REST appears through that client, so you can see these details that were hidden from you before. I guess the other way to look at it would be, do we want to expose these differences and have clients having to deal with it? I mean, if you're getting the runtime object back, and it's usually the full resource, but sometimes it's a status object, and you have to know which one.
I mean, I like our client being sort of dumb, and so like the server is sending back something. It might be a status, it might be an object, it might be a pod. Like it depends on the object, I guess. I kind of want our client to just give that back to the caller and not try to be too smart about getting in the way of that.
I think I'm okay with that. I mean, that's if that's what the REST API gives you, then we wouldn't want to make you fight with the client, right? You should be able to get what you can get.
I mean, separately, we probably want like an integration test that tries the types of objects we have, the ones that return objects, the ones that return status, what happens with graceful deletion, what happens with the finalizer, what happens if you delete an object that already had a deletion timestamp but still has a finalizer, like we want to exercise those things.
Right.
But just making the client, like, I did a delete, I got an object back, here it is, seems like the right thing to do.
I'm okay with that.
So then this is where you get into that case where there isn't actually a resource version sometimes.
Yeah. So there's the cases, I think there's mostly the case where there's two concurrent deletes happening at the same time. I think every other case, the object either exists inside of the store or we're the one doing the deletion. It's mostly when it's a race where there's two different things happening concurrently, and we don't want the second deletion to have succeeded in the sense that something else did the deletion at the exact same time as us and still return an error. I think this is there was a long-standing issue for some time where these things would cause errors when I think it was pod deletions or certain things, like it caused flaky integration tests if all of these things actually return their own errors in these cases. But what we decided to do is that the last known, the last resource version, the resource version that we actually queried the store at is just going to be the resource version that one returns, because that's the known state that the object is deleted inside of the store. It's kind of like the best known resource version at that point in time.
So the current behavior, when we return an object, the current behavior for types which return the object on deletion, I think they actually just return their last seen object, which has the resource version that was last seen, which is wrong, actually. For types which don't return the object but return a status, I think today they just have, there's no resource version on the status ever. So clients who are getting back objects can't trust the resource version currently, because it might be the last observed one in the case of a race, or it might be the actual deleted one. And clients that are getting back statuses aren't getting back any resource version, so they already have to handle a status with no resource version. I think we can be strictly better by, when we are the ones to do the delete, returning the resource version we did the delete at, or the persisted deletion timestamp at. What we do when there's a race, I could either see returning no resource version, or returning the resource version that etcd gave us when it told us the thing you're deleting does not exist at this version. We have the actual version from etcd where we know the object is absent. I could see cases for both. I'm curious what David or Joe or anyone else think would be better there.
So if something is in the process of being deleted, and I issue another delete, and it's one of the ones that gives me the full object, you think that it gives me the resource version of the last update when that delete happened?
When your request drives a write, I think, I've traced it through, I could be wrong, there might be edge cases, grain of salt. When your request drives a write or a delete, I think you get back the resource version of that write or delete. When your request races with a concurrent delete and the object was actually gone, I think you get back the
Yeah,
last observed resource version.
Yeah,
which
Would
is
match what you would get if you did a get of the same object, right?
If you had done a get prior to the racing delete.
Yeah,
Yes.
and I think
Yes.
we're running low on time, so I don't want to take too much from the next two. I don't know if
maybe the thing to do here would be to enumerate the weird edges and list out what do we get today, and then what are we proposing to change it to. That a table like that might help clarify.
Okay.
Like, what are the current things we think are correct? What are the current things we think are wrong? What are the current things we think are missing but would be useful if we could provide? And then what we're proposing to change them to.
Okay. I don't think I'm fundamentally against adding it. The API is pretty strange. There are many, I guess a thing that I actually just don't know. I know that I can have two deletes, they happen at the same time, and they both succeed somehow, because I've done that many times. I actually don't know what happens if I do a delete and it actually needs to get finalized, and I do another delete and it's already in the act of being finalized. I don't know whether that succeeds or fails.
It succeeds.
So even though you might actually say, like, David, you should know, David doesn't know. And so it would be helpful for me to have that behavior in the table.
It's okay, David. People who are familiar with the API really know what it
means. And maybe a comparison against what a get would look like. Because if you can multiply delete a thing in the finalization process, and I think I can, then I think the result that I get as it goes through multiple finalizers and gets more and more rights given to it, I think that resource version changes, and I don't know which one you're proposing I get back. So apologies if you have that table and I didn't notice.
No, I didn't, so I'll add that in.
Okay. And then in terms, I guess, I think it'll also be important to explain and document to people that this does not mean that they can, like, use this deletion thing to indicate when something's removed from a cache, because I don't think that's what that means. And it'll be, I guarantee controller runtime will be wanting to do something like that. But I think deletes succeed and you get a resource version that is not when the thing was deleted, which is important to note.
Okay, and I think that unfortunately the other two topics, assuming this one, we are at the end of the time that we have. So anyways, so we will have to wrap it up here. And sorry for the other two topics. Hopefully we can move them for next week. And if anything is critical, time sensitive, ping me separately and we will find time to discuss this offline or online. Okay. Thank you everybody for showing up and sharing your brains here on these good discussions. We'll see you next time. Have a good rest of your week.